Hey there, welcome back to another video with the Math Doc. We are continuing with the set of videos on the basics of what functions are. And if you haven't seen the previous video, check it out. If you're new to this channel, you can check out the other videos as well. In the previous video, we actually looked at the definition of what a function is, and we used one simple example, which was the example of the price of peaches. And we're going to use that same example here. So we said the price of peaches, y, equals 2 times x, where x was the pounds, right, of peaches, and y is the price in dollars. And we used that example to kind of look at how we define a function. In this video, we're going to look at a function a little bit like a machine, where you have an input. These are our inputs. So here we'll have our peaches, but actually we'll look at the weight of the peaches, the number of pounds. And our output will be the price that we will pay at the market. And we know that we pay $2 per pound. So that is our function, or our machine in this case. And we have our input set here, which is 1, 2, 3, and so on, all defined by the variable x. And we have our outputs here, 2, 4, 6, right? We have only the even numbers because each pound costs $2. And the output is presented by this variable y. And we can write our sets here of input as 1, 2, 3, and our outputs here were 2, 4, 6. Now, the domain of a function, and you may have seen this, this definition, although if functions are new to you, then this definition might be a little bit confusing, but the domain of a function is the set of all possible input values. In this case, we can have any number of pounds, right? So it's really all these integer numbers. We can't have negative amount of peaches, so it's positive numbers, right? So let's write that here, positive numbers. And our outputs are basically the same numbers times 2, which means it's all the multiples of 2, or all even numbers. So all positive, again, we pay a positive amount for the peaches, all positive even numbers. So that is our set of inputs and outputs. So the domain here is the positive numbers. This is the inputs. So the domain of a function is the set of all possible inputs, while the range of the function is the set of all possible outputs. So this is the range. It's all positive even numbers. And that is because we haven't limited the amount of peaches that we can buy. But what if the store allows every person to buy only between 1 and 5 pounds? So shoppers are limited. They cannot buy more than 5 pounds of peaches. In that case, we can have as domain, let's start using this terminology. We can have 1 pound, 2 pounds, 3 pounds, 4 pounds, and 5 pounds. So our domain is limited. It is finite. It is only these numbers. And what is our range? Again, the range are the outputs. Well, 1 will cost $2, so it will be 2. 2 pounds will cost 2 times 2, which is 4, so on. So 3 pounds will cost 6, 4 pounds 8, and 5 pounds 10. And so our domain is this set of numbers, 1, 2, 3, 4, 5, and our range is 2, 4, 6, 8, 10. So in this case, our domain and our range are finite. We can have various cases. We can have a system where we're actually measuring, say, the temperature of something, and it depends on how much heat we put in. In that case, the temperature range, right, can be from absolute 0 all the way to positive infinity, right? temperature can, strictly speaking, be as high as we want. So in this case, it's not a finite domain or a finite range. Rather, it starts at a certain point and it goes all the way to infinity, or it's an unending, unlimited set of values. We can also have situations which are even stranger. Let's, for instance, look at a different case. For instance, we can look at the temperature of water as we heat it. Now, you may know already from science that water can't go above the boiling point. It then turns into steam. So if we are putting a pot of water, and excuse my drawing, on a flame here, right? It'll heat up. Let's put in a thermometer. And we can look at the temperature as a function, or as a function of time. So if our x now is the time from start of heating, we may have started, say, at some temperature. Here, let's say we started at the temperature of 70 degrees Fahrenheit. We can go all the way up to 212 in a certain amount of time. But once it hits 212, it stays constant. So our domain, right, which is the amount of time that passed from starting to heat. So domain is the possible times can go all the way from 0, right? From we start at 0, could go all the way to positive infinity. Our domain is really what we would call half infinite. It goes from time 0, when we started this flame up here, to infinity. What about the range? Our range is temperature. So domain is time, and it's unlimited. Our range is water temperature. And our water temperature can go from 70, because that's where we started, up to 212. Right? That's in Fahrenheit. That's where water boils. But it will not go further. So our range is a limited set. But our domain is a semi-infinite or unlimited set. We can have other situations as well. Let's look at another final example. And this example is a little more artificial, but again, it might be true. For instance, let's look at how much we pay for parking, okay? So the price of parking. Now, the price of parking is usually determined by how long we've parked in a certain parking lot, right? But usually it's not a continuous function, meaning we jump. Every hour we pay another certain amount. So we can have our range, our domain, let's say, can be from 0 to, say, 12 hours, okay? And any fraction of that, right? We can stay 15 minutes, we can say 2.5 hours. So our domain is from 0 time to 12 hours included. Okay, but we pay now in increments of 1 hour. What does that mean? It means that for first hour, we pay, say, $1. Second hour, we will pay $2, and so on. Now, if we graph this, if this is, again, time here, so x is our parking time, and this is our payment, y. For the first hour here, we pay $1, right? For the entire second hour, we pay $2, right? All the way here. For the entire third hour, we pay $3. So we really have something that is more like a step function. And so if our domain here is a continuous set, our range now is basically 1, 2, 3, 4, and so on until we reach our 12th hour, which is between 11 hours and 1 second and our 12th hour, and then we pay $12. So our range is a very limited set, is just 12 numbers, while our domain is continuous, and we can have any fraction. So any fraction, and here it's only 12 integers. So this is another example of how a domain and a range look. So this brings this video to an end. If this video was helpful, please like. If you have any questions or comments, please include those in the comment section below. If you haven't checked out the other videos on functions, please see the playlist identified in the info button. Okay, see you next time.